ஹலோ.
எஸ் மேம்.
அனுப்பிவிட்டேன். வாட்ஸ்அப்ல அனுப்பிவிட்டேன். நீங்க மேம் கேதர் பண்ணுங்க. நம்ம அந்த லிங்க்ல ஜாயின் பண்ணுங்க. சிவரஞ்சனி 2 செகண்ட் மட்டும் வெயிட் பண்ணுப்போம்.
ஓகே மேம், நோ இஷ்யூஸ் மேம். லிங்க்
ஓகே
ஜாயின் பண்ணிட்டேன் மேம். நீங்க சொல்லுங்க, ஸ்டார்ட் பண்ணுங்க.
ஓகே கண்ணா. ஓகே.
Hello, Sivanjini. Hello.
Yes ma'am.
Can you hear me now?
Yes ma'am. Audible.
Okay, I'll just ask the HOD ma'am. Let us make some students to join. அப்புறம் ma'am introduction கொடுத்துட்டு இருக்காங்க. கொடுத்ததுக்கு அப்புறம் we can start the session ba.
Okay ma'am, no issues.
Okay pa, thank you. Ma'am link வந்துச்சு, நான் டெஸ்ட் பண்ணிட்டேன். இன்னொரு 10 செகண்ட் தான். நான் இதுலயே
மேம் விசாலட்சுமி மேம். ஹலோ. மேம் ஜெபி மேம். ஹலோ. வரேன். ரீசன் எதுவுமே இல்லை. பார்க்கலாம் இருக்கவங்களை கூட்டிட்டு வந்தா ஏன்பா.
ஹலோ. மேடம் மேம்.
மேம் நீங்க தான் ஸ்டார்ட் பண்ணிக்கலாம் மேம்.
வாட் ஸ்டூடண்ட்ஸ் ஜாயின்.
ஓகே மேம், தேங்க்ஸ்.
Hello?
கேக்குதுங்களா? சிவரஞ்சனி மேம் ஸ்டார்ட் பண்ணிக்கலாங்களா?
Yes, ma'am. Start பண்ணிக்கலாம்.
Very good afternoon, students. Can you hear me?
Yes, ma'am.
Okay. Siranjani ma'am?
Yes, ma'am. I can hear you, ma'am.
Okay. So today we are having a session on network simulator, and our resource person is actually Siranjani ma'am, and she is working in our college, and then but actually a very active person, and then she is currently doing her research in transmission control protocol for wireless multi-hub networks, mainly for ad hoc network and as well as mobile ad hoc. And then very fortunate to have you, Svanjani ma'am, for this session. So welcome, and then welcome Sivanjani ma'am. And then because we are all in a very busy schedule, but even though you accepted our invitation, and then you give us time to teach some basic few things about the network simulator. So now I also share some of things with you people. So this NS2 is nothing but we all know that it's a network simulator version 2, and it is open source event driven simulator designed specifically for computer communication networks. And then so if you are saying even some of the features of NS2 means this particular thing support, simulate bunch of protocols like TCP, FTP and everything, and as well as it simulates the wired and as well as wireless networks, and it is using Unix based, and also it uses the TCL scripting languages also. Okay, right. This having the two sessions here we are having the important things, two key languages here we are using. One is C++ and as well as object oriented tool command language. Okay, so this particular thing we are using for networking, and hope this particular another 2 hours will be an eye opener for you people, and then you'll learn something about the network simulator. Okay, so make use of this opportunity, and then learn something so that it is very helpful for you people, and also it is helpful for your laboratory purpose also. So once again I welcome the gathering, and as well as the organizers who organized this one, Dr. Manaha ma'am and as well as Sarakshi ma'am. And then because it is a very useful session for the students, so it is right time you are organized, and I congratulate the organizers, and also once again I welcome the resource persons Sivanjani ma'am and as well as all the students. So thank you ma'am. Sivanjani ma'am, please.
Thank you, ma'am. Thank you for providing opportunity, ma'am.
Thank you.
Okay, let's share screen.
Okay, sure. Yes.
Okay.
Okay.
Is my screen visible, ma'am? Yes, anyone?
Yes, ma'am. Yes, ma'am.
Okay. Okay, ma'am. Thank you. Okay. A warm good afternoon to everyone. So today we are going to discuss about network simulator and then basic topology, how to create different topologies using NS2. Okay, I am Sivaranjini, Assistant Professor, Department of ECE in our college. Okay, what is NS2? Does anyone know about NS2 network simulator? Students, any idea? Okay, it's an open source network. Okay, for example, if you are buying using any software, means you have to pay for the tool and then you have to use it. But NS2 is open source and free. You can download and then simply you can use it. But you have to use this in Unix platform. Okay, and using in a Fedora platform, you can use in Ubuntu. You can use in Red Hat. You can use in any platforms. So it's a event-based or packet-based simulator. For example, using NS2, you can track a packet when it is generated, when it's traveling from one node to another node, when is it delivered to receiver. Like that, you can analyze the entire packet in the network. Okay, it uses two languages, that is C++ and tool command language, that is TCL. Using this, you can design both wire network and wireless network. So today we are going to discuss and analyze about, and we are going to design a network in wired environment using different topologies like bus topology, star, mesh topology. Right? We can design the topology and then we are going to analyze the performance in the network. Okay, as I said, NS2 uses two languages, C++ and TCL. So C++ is used in the back end and then TCL used in the front end. Because what is C++? It's object-oriented language. Okay, it's easy to design, but if you want to change a single code, you have to compile and then you have to again generate the object file. But in TCL, it's a fast running program, and then to designing a coding in TCL is too simple. So in NS2, what they have done is they have compiled two languages, C++ and TCL, and then they have linked this so you can run a program at faster time. Okay, as it's mentioned, TCL is used for front end and C++ is used in the back end. Okay, you can track, you can control, you can manipulate uh, back end C++ object using the front end TCL code. Okay, these are the functions what you can do in NS2. That is, you can create an event simulator, you can create a different network, for example, wire network, wireless network. You can design a routing protocol, you can insert errors and then you can analyze the performance. You can design transport connections, you can design transport layer protocols like TCP, UDP, and then you can create real-time traffic and then analyze your performance using this NS2. Okay, next we are going to a program, right? So first, we are going to design a simple point-to-point protocol. Right? What is point-to-point protocol? Can any student answer, please? What is point-to-point? Okay, that is one-to-one communication. For example, if a sender is there and a receiver is there, they will communicate directly, right? For example, if you want to send a message from your mobile phone to your friend, what you have to do? First, you must have a phone, and then your friend must have a phone. After that, what I have to do? You should have a working SIM, and then your friend should have a working SIM. After that, you have to create a message, and then you have to send that message via this network, and then your friend will receive. Okay, this procedure should be same replicated in the NS2. Okay, first what I have to do in the simple point-to-point network, I have to create two nodes. Okay, I have created first node in the name of N0 and then second node in the name of N1. Okay, simply I have purchased two nodes. After that, what I have to do? I have to link these two nodes. Okay, so the command to create a single node is you have to use the command called set. Okay, before creating a node, you have to first create a simulator. Right, so in order to create a simulator, you have to use this word set ns. So new simulator. I think everyone know about this C++, right? So in order to create, in order to access a class, what you have to do? You have to create an object, and via this object, you can access any class or any objects in this class, right? So here, in order to access the simulator, first I have to create an object in the name of NS. Okay. So for the step is what? Set NS new simulator. What it will do? It will simply create a NS object in the name object in the name of NS, which is used to simulate the entire thing. Yes, this NS is what? A scheduler name. So after that, what I have to do? If you run a NS2 coding, right, you will get two outputs. So first one is trace output, second one is NAM output. So trace output is used for so packet analysis. For example, if you want to analyze the performance of your designed algorithm, for example, you want to analyze how many packets I have transmitted, how many packet drops occurred in the network, right? How many how much energy consumed node is consumed, right? If you want to analyze, this trace file is used. Okay, for example, if you want to see visually on a graphical view, this NAM file is used, right? So you have to save this NS2 coding in the name of .tcl, because front end we are using OTCL language. So I have to save my code in the name of what? .tcl. For example, I'm saving my example as code as example. So I have to save it as what? Example.tcl. Okay. So if you run a .tcl file, you will get two outputs. So first one is what? TR output. Second one is what? NAM output, right? So you have to open these two files. So for this, I am using this command set f open out.tr with w. That means what this line says is I am setting a variable f which is denotes the out.tr. So what it will do? It will open the out.tr file. What w means? W means with write mode. Okay. So if this line is executed, what will happen? The simulator will generate a file in the name of output out.tr with write mode. Okay. After that, what I can do? I can simply trace all the trace file to what? This file. Okay. The next line is used to trace all the files and is used to dump the trace file to what? Out.tr file. So $ns trace all $f. So in C or C++, what you will do, when the first time you initiate a variable, you will simply give the name, for example, int A, int B. For the second time, what you will do, you will use ampersand, right? In the same way, in TCL, you have to use this dollar symbol, okay? So I have initially used NS and F. I am recalling this same variable. So what I have to use? I have to use dollar, okay? So $NS trace all $F. What it will do? It will trace all the event and then it will what? It will write into out.tr file. The same way in the NAM file, what it will do? I have to open my NAM file. So set NF open with the out.nam file with writing mode. So if I want to access the NAM file, in order to trace, yes, this NAM file to actual simulator, what I have to use? $ns NAM trace all and $nf. What it will do? It will trace all the NAM files and then it will dump into what? Output out.nam file. So it's just an overview. We will do a real-time example. Okay. So first what I have did? A simulate dot file NAM file. So after that, what I have to do? I have to create two nodes. Right? So in order to create a node, we have to use this line. For example, say n node. So in the square bracket, you have to use what? $ns node. So node is an class. Okay, you are using that. You have to use the class with the simulator. So I have used this $ns node. So I have to give the class name, object names for this class. Okay. So in this diagram, I have used n0 as my node 1 and then n1 as my node 2. So I am using save n0 $ns node. What it will do? Simply in the name of n0. Okay. For the second node, what I have to do? Simply I have to use set n1 $NS. If you execute these two steps, what will happen? It will simply create two nodes in the and N. I have to link these two nodes, right? So I have to link N0 and N1. So for this, you have to use this. So for every instruction, you have to use this simulator. So it must have what? $NS. Okay, $NS. So what is this link between N0 and N1? It's a duplex link, right? I have to use this command. Right? Because I have mentioned the variable as step, so I am accessing the same variable. So what I have used, okay. So link has what? Some capacity, right? So I have to mention the capacity. Link has 1 MB band. 10 can each of packet stop this or node N1. Then drop what? It's a so I think everyone familiar of this queuing technique, right? So I'm using simple queue, right? So drop tail queue. Okay? So first what I have to do, I have to create two nodes, that is N0 and N1. After that, what I have to connect these nodes, right? So I'm using this command what? Duplex. So I have to use two. Voice is breaking. Okay, just a second. I think, is it clear now? Am I audible? Yes, okay, thank you. Okay. What I have done, in order to use what so I have created N1. After that, what I have okay. So I have used this code what nam file what is file. So after that, what I have created two nodes, and then I have created a link to connect these two nodes. Okay. So right, then at last what? So you have to see. So for this, you have to use this $NS at some time. You have to mention sometime. You have to use this command called finish. Again, voice is breaking. Am I audible now? Yes, it's clear. Anyone reply, please? No, it's not audible. Yes. Okay. Just I'm continuing. Okay. So I have created what? I have created a simulator. I have created a NAM file. I have created trace file, and then what I have done, I have created two objects, right? So N0 and N1, and after that, what I have connected these two nodes. Then at last, what I have to do, I have to finish this simulation, right? So you have to use this word, this last line, $NS at you have to mention some time, and then you have to use this keyword called finish. So finish, what it will do is it will finish the entire simulation. So I have mentioned this finish function in above. Okay, see this procedure for finish. So in this you have to globally include the variables. Which are the variables you have used in the coding, right? So in the coding, what I have used the NS, I have used the F, I have used the NF. So in the finishing procedure, I have to declare all these variable in global. Okay. After that, what I have to do is I have to flush trace. That means for every program, if you run, it will store the output in what? In temporary memory, right? So when you run an NS2 program, the output will be what? In terms of MBs and sometimes in terms of GBs, right? If you start to, without deleting these files, if you start to work again and again means your system will get crashed. So after completing this simulation, what you have to do, you have to remove the entire trace file, right? So for that, you have to use this $ns plus trace. So what it will do is, it will not delete the out.tr, out.nav file. What it will do is, it will simply delete temporary file stored in the your C, C drive, okay? So after that, what I have to do? So I have opened out.tr and out.nav file with write mode, right? So before closing the program, what I have to do? I have to close the files, right? So here, so you have to use what? Close $f and close $f. So after that, what you have to do? You have to give exit 0. So this indicates that your program gets completed without any error. Okay. So this is the sample coding. Okay, so in this coding, did you see means I have just created a two node, okay, and then I have created a link, but I didn't transmit any packets, right? So next step is you have to create a traffic, okay. So traffic in which layer it will come? So I think everyone know about this OSI layer architecture, right? How many layers present in architecture, OSI architecture? Anyone answer me?
7 layers, ma'am.
Yes, 7 layers. Okay, thank you. Okay, so in traffic, so transport layer. So did you know anything about transport layer? So you can create and generate any traffic using this what? Transport layer, right? So did you know any protocols in transport layer? It's a connection oriented protocol and then connectionless protocol. So mainly in transport layer, you will have two protocols, right? TCP and UDP, right? So we are going to design both TCP and UDP protocols. Okay, so first we are going to design a UDP protocol and then we will see about this TCP, right? So first what I have did, so I have created two nodes with the name of N0 and N1 and then I have created, so now I am going to assign UDP traffic, that is N0 as sender and then N1 as receiver. So this is the coding for that, right? So what I have to do, so N0 as sender and then N1 as receiver. So N0 is sender, so I have to assign UDP protocol to what? N0 and then you have to use some traffic, right? CBR means constant bit rate. So I will generate a traffic using CBR and then I will transmit using UDP protocol. So the lines for this, so as usual. So in order to create what? So UDP, in order to access a UDP protocol, what you have to do? You have to create an object. So I am creating an object in the name of CBR0, right? So it is present in the class name called application traffic. So application is a parent class. The traffic is a child class. So CBR is a child class of traffic. So I have to mention this, okay? So I am creating an object in the name of CBR0 from which class? CBR class. So after this, so each packet gets right. So what are the characteristics of a packet? It has packet size. So in CBR means what? So I can mention at what interval I have to send next packet, right? So these are the some basic variables. You can give or simply you can neglect, okay? So for my example, I'm using as packet size as what? 500. And then interval size as what? 0.05 millisecond. So what it will do? So N0 will act as a sender, right? So what it will do? It will send a packet in the size of 500. So which at 0.05 millisecond interval, right? So here you have just created what? CBR, right? You didn't attach the CBR to what? So UDP. So what you have to do? So in the first step, you have to create UDP. Right? So first in the node N0, you have to attach UDP. So in order to create this UDP protocol, the command is set UDP. That is, you have to mention some object name UDP0. So after that, what you have to access that class name. So UDP is present in the class called agent. Okay. So you have to access what? So new agent slash UDP, and then I'm using any name value. For example, I'm using UDP0. So you can use ABCD, or you can use UDP2, you can 4, you can use any variable name here. That's not a problem, right? So I have created a UDP. So after that, what I have to do? I have to attach this UDP to what? N0, because N0 I have in this program I have assumed what N0 as a sender, right? So I have to attach this UDP to what N0. So this command line is what $ns attach agent $N0 and $UDP0. So what it will do? So it will attach this UDP with what N0. So after that, what I have to do? So I have to use this what CBR traffic, right? So after that, what I have created a CBR. So and then what I have to do? So I have to link this CBR to what UDP. So this command line is what $CBR0 attach agent. So I have to create attach the CBR to where? So you can see in the diagram, right? So I have to attach where? In the UDP. So the command line is what $CBR0 attach agent $UDP0, right? So first what I have to do, I have to create nodes. After that, what I have to do, I have to create UDP, and then what I have to do, I have to create CBR. So I have to attach UDP to N0 and then CBR to what UDP. So in the receiver side, in the UDP, does any receiver send the acknowledgement? Can anyone say? Does UDP has acknowledgement? Say yes or no? Yes. Any other answer? I think everyone knows that TCP has acknowledgement, right? So for every packet, how TCP will work? So TCP sender will send a packet. After acknowledgement, it will send the next packet, right? So in UDP, there is no concept called acknowledgement. So receiver will not send any acknowledgement in UDP. So I have to simply what? Set null to receiver. So that's why see in this line, set null new agent null. Okay. So receiver does not send any packet. Okay. So after that, what I have to do? So I have to attach this to what? My receiver N1. So I have attached this agent, attach agent N0, N1 and then null. So what I have did? So here I have null 0 means what? My receiver. So I have attached this null 0 to where? My N1, because N1 is the receiver. Okay, after that, so here up to this, what I have done? So I have separately attached protocols for sender. You have separately attached protocols for receiver. So now what you have to do? You have to combine this what? Sender and receiver. So steps to connect is what? $ns connect. So what is the UDP protocol for sender? So what I have used? I have used $UDP0. So for the receiver, what I have used? Null 0. So I have to attach these two. So step to connect is $ns connect $UDP0 and then null 0. So this line will connect both sender and receiver. So after that, what I have to do? Simply you have created nodes and then you have connected links. After that, what you did? You have created protocols for sender side and then you have created protocol for receiver side. After then you have connected. So till now you didn't send any packet, right? So you have to start sending at some particular time. So that is this. So $ns at 0.5. Okay. So which CBR packet you have used? I have used CBR as well. CBR 0. So I have to start that, right? So at NS, so at 0.5 means at 0.5 seconds, I will start my CBR packet. Okay. So I will show the example, then you will understand. Then you have to stop the simulation at some time, right? So at 4.5 seconds, the CBR will what? Stop the sending packets. Then at $NS5 means what? It will recall the ending procedure. Okay. Then after completing all this, what? This $NS run. So after giving only this command, your entire program will get executed, right? So this last line is very, very important. Okay. This is a traceful analysis. Okay. So we will see this later, right? So this is a basic trace file format. So if you are running, so after simulating your TCS file, you will get two outputs, that is .tr and then .nam. If you are opening .tr file, you will get output like this. Okay, this is arranged in the format. So first is event. Okay, so we will discuss this later. So event, from which node is it coming and which node is it going. So what is the source address, what is the destination address, what is the sequence number. We can everything we can analyze from this trace file. So I think you are clear about this UDP, right? So next we are going to see about TCP. So TCP means what? It gets acknowledgement. So in the sample scenario, I am going to create nodes. For example, here sender 1, sender 2 and sender 3. So what I have to do? I have to create node called set S1. So for creating a node, which line I have to use? I have to use what? $NS node. So for S2, the same. For SG, same. I am using a gateway. I am mentioning this gateway as G. So I have to use set G $NS node. For the receiver, I am using what? Set or $NS. Simply, I have created nodes. Yes. So next, I am creating a TCP protocol. So these are the lines to create TCP protocols. In order to create a TCP protocols, you have to use this, right? So new agent slash TCP slash Reno. So Reno is a type of TCP protocols. You can use Reno, New Reno, Vegas, Westwood, right? Compound, Cubic. There are n number of protocols are available in TCP. I am simply using what? Basic TCP protocols, that is Reno, right? So in order to access this Reno, what you have to do? You have to, as usual, you have to create an object. So I am creating this object what? In the name of TCP1. So after that, what I have to do? I have to attach this N1. So I am going to attach this TCP1 to what? Source 1. So I am using this command called $NS attach agent $S1 and then $TCP1. What it will do? It will attach this TCP connection, that is TCP1 to what? S1. So after that, so I am setting the window size, right? So I think everyone know about this window size. So what is window? For every TCP works in the concept called window size, right? First, what it will do, it will send 1 packet. After that, it will send 2 packet, 4, 8. Up to what? Which size it will increase? So receiver's maximum advertised window, right? That is, I have denoted this as window. For example, from S1 to R, so how much packet it can send at a time? At max, it can send 8 packets at a time. Okay. The next line is what? $TCP set FID1. That means in order to differentiate different flows in the network, I am using this concept called flow ID. So simply I can track which flow is coming in this. So which flow causes congestion. Okay. In order to analyze this, I am using this flow ID. So you can simply neglect these 2 lines. So you can use first 2 lines. So simply TCP will work fine. The same way for S2, I am creating another TCP protocol. So which line I have to change? I am simply copying the previous slide and then pasting. So, but what I have to change? I have to change simple variables, which I have to change. Instead of TCP1, for the second connection, what I have used? TCP2. The same way, instead of source 1, I have used what? Source 2 here. So instead of TCP1, so for source 2, for source 2 what? I have to attach TCP2. So I have attached what? $S2 to $TCP2. The same way, for S3, I have to what? Attach TCP3. So what I have done? I have same copied and pasted. So I have changed what? TCP2 as TCP3 and then changed what? S3, source 2 as what? S3 and then TCP2 as what? TCP3. Okay. Remaining everything is same. Okay. Here in the, this is all from the sender side, right? So receiver side. So in the TCP, the receiver will have the capacity to what? Sending acknowledgement. So for the sync node, we have to use this concept, use this line. For set sync, so new agent slash TCP sync. So in order to set the node as a receiver, we have to use this line. So new agent slash TCP sync. Okay. So I am, for this example, I am sending S1 to OR, S2 to OR, and then S3 to OR. Okay. So for S1 to OR, it will act as a OR, acts as a sync 1. For S2 to OR act as a, again a second receiver. For third communication, it will again as a receiver. So for the same name, I am created the 3 links. So you can see So I have created sync 1. So new agent plus TCP. So after that, what I have to do? I have to attach this sync to different receiver. So in my case, what? So R is a simple receiver. So I have given what? $NS attach agent $R $sync 1. What it will do? Simply what? So first in the first case, sync 1 is attached to what? Node R. So in the second case, sync 2 is attached to R. In third case, sync 3 is attached to R. Yes. So after that same way, till now what I have done, so I have simply created sender size differently and then receiver size differently. After that, what I have to do, so I have to link this sender and receiver side, right? So in order to connect what line, what command you have to use this command called connect. So I have to connect what? I have to connect TCP1 with what? Sync 1, TCP2 with what? Sync 2, TCP3 with what? Sync 3. I have just connected $NS connect $TCP1 with what? $sync 1. Same way you can repeat for n number of connections. Right. So you have simply connected from source and destination. So after that, what you have to do? You have to generate packets and then you have to send actual packet, right? So in order to send packets in a TCP protocol, you have to use FTP. That is what? File transfer protocol, right? For UDP, you have to use CBR, constant bit rate. For TCP, you have to use what? File transfer protocol. For this command is what? So for this FTP, what I have to do? The same way. So FTP is present in the parent class of what? Application. So I have to mention as set FTP1 new application slash FTP. That means, so for this TCP1 connection, what I will do? So I will create a separate traffic file in the name of FTP1. So that will come from what? Application slash FTP. For next, what I have to do? So I have to attach this FTP1 to TCP. The same way what we have did in UDP. So we have connected CBR 0 with right UDP 0, right? So same way here we have connected to what? FTP1 with what? TCP1. Same way FTP2 with TCP2, FTP3 with TCP3. Yeah, the same procedure. So this is the procedure for finish, and then last part I have to start my transmission, right? So in order to start my transmission, what I have to use? I have to use $NF. You have to mention sometime. After that, what I have to use? You have to use. So in the previous cut, what you have used this $CBR0, $CBR1. For this case, you have to use what? $FTP1. So and then you have to make start in order to start. So in order to stop, what you have to do? So after sunshine, you can use $NF at some time $FTP1 stop. So it will stop sending your packets. After that, at last, what you have to do? You have to use this. You have to call this finish procedure, and then at last, you have to run this NS file. Yes, this is a trace file format. I think we will go for example, then we will analyze. Yes. Okay. In order to run NS2, you can run in Windows, but it takes so much of time to run a simple program. Okay. Best advisable is you can use any Unix platform, right? For example, I am using Fedora. So this is a Fedora environment. I'm using this Fedora in virtual OS. Okay. So in this OS, if you see this top left corner, you can find activities. If you click here, you can find this search bar. In the search bar, you have to give terminal. Yes. Yes, it's loading. It takes some time. So before this, I will open your program. Yes. See, if you are using virtual OS, right? So it will take some time. So better advisable is try to install in any system, right? I think you have installed two systems into your lab. You can go there and try. Basic terminal. Terminal means it's like a command prompt, right? So you have to work everything here in terminal, right? In order to execute, you can analyze everything in the from the terminal window. So this is your program. Simply I am taking a point-to-point protocol. Yes, visible, lines are visible, right? This is the basic coding. So what I have explained in the PPT, right? So first what I have did, so I have created a simulator. So after that, so this is just to color the packets which are transmitted in. So after that, what I have did, I have created trace file and then NAM file. So this is a procedure for finish. So in this extra, what I have added, so I have changed what my NAM file. So in order to differentiate different NAM files, what I have done is, so I have saved this TCL file as what? P2P-TCP.tcl. So in the same way, I have saved my NAM file in the name called what? P2P-TCP.NAM. So you won't get any confusion because if you see, I have different files. So if I simply save any protocol in the name called 1, 2, 3 means what? So if I open in the future, I will get confused. So it's better advisable is what? So if you are saving a file in .tcl means the same file should be what? Should be saved in .tr and then in .nam. So in point-to-point P2P TCP means the next I have created two nodes. After that, I have created duplexing between these two nodes, and then I have created a queue limit. So this is optional, right? You can neglect this step, and this is also optional. Optional. Okay, I will explain this later. So it is just to assign the position of your node. The next one is a TCP connection. So for TCP, what I have to do? So I have to create what? TCP agent. So I have to attach this to sender. After that, what? I have to create TCP sync, and I have to attach this what? TCP receiver. And then what I have to do? So I have to attach TCP source and TCP sync. Then I am giving flow ID. Then after that, what I have to do? I have to give FTP protocol, and then I have attached this FTP to what? My TCP protocol. Then at last, what I have to do? So I have to start my TCP connection. So I am starting my TCP connection what? At time 1. So I have stopping my TCP connection what? At 4. Then this is optional, okay? You can neglect this. See, if you're attaching your TCP source and sink, right? So this is the lines to detach your sink and source. So this is the last procedure. Then at last line is, so at last line is what? $NS run. Yes, you can see here. Last line is, it's compulsory, right? If you after running this only, you will get executed. Your file get executed. Simply I am saving. Just I am closing this file. So to run your TCL file, you just go to where? Your terminal. Go to open terminal, right? So you will get this hash prompt, right? After that, you have to do everything. So right, where I have saved my programs, I have saved my programs in home and then in the folder called what? Program. So first I have to go to this program folder. So for this command is cd program. So in this program I have used capital P. So I have given just giving enter. So currently now what I am giving PWD, that is program. So PW means what? Present working directory. So currently I am in where? So in the home and then in program file. So now, so which file I have opened? P2P hyphen TCP.tcl. So I'm just simply running this file. Okay, how to run this file? NS. So you have to use this command what? You have to use this command called NS. After that, what? You have to mention your file name. So what's my file name? My file name is pc hyphen tcp dot tcl. Is it clear? In order to run my TCL file, which command I have to use? I have to use NS and then you have to use what? Full file name, that is p2p hyphen tcp dot tcl. Just I am giving enter. Okay. Just a second. Yes. So after executing this part, you will get hash like this. So when you want to open your NAM file, that is your animate file, you have to give what? This command called NAM and then you have to give that file name. So in which file name you have saved your NAM file? So you have given what? You have given this P2P hyphen TCP dot NAM. So you have to give her, that is NAM P2P hyphen TCP dot NAM. Yes. So I have created two nodes. That is what? So 0 and then 1. So in order to simply run this, you can see this play button. If I'm clicking this, the simulation is running. You can see this time is varying here. Right? Can you see? packet is going. What is this? Small size. We have designed which protocol? TCP, right? So TCP, what it will do? It will send acknowledgement. So for node 0 to node 1, this bigger packet is sending. That is, this is my actual data packet from node 1 to node 0, which is sending small packets. That is, this is my what? This is my acknowledgement. Yes, what is this? This blue color at N0. This is packet drop, right? Because what I have done, so we have assumed this packet size as what? 500 and then queue size is what? 10. So if this queue size exceeds, simply the packets get dropped. This is my sample scenario. This is for TCP. Same way for UDP. UDP, what I have to change? Everything is same, right? Simulator line is same color, same trace file, same NAM file, same finish command, and then after that, same. I have created 2 nodes. After that, same creating a linking command. After that, same queue limit. After that, what? Orientation. So, which lines I have to change? I have to change only these lines because I'm using the same point-to-point protocol. So I have to create same 2 nodes, N0 and N1. So from in this, what I have to change? I have to change only this as instead of TCP, what I have to change? I have to change UDP. So I have changed only these lines. Okay. So I will run. So NS, what's the file name? So P2P, you can see in the top, right? So P2P hyphen UDP .tcl. So go to terminal. So how you can run? You have to give what? NS P2P, sorry, P2P hyphen UDP .tcl, right? If you run this, you get this. So simply I am paying this connection. See in this, what's the basic difference between this simulation and then previous simulation? In the previous simulation, you can find what? You can find acknowledgement because that is what? TCP connection. In TCP, for every packet received, right, the receiver will send acknowledgement. Here, which simulation we have executed? We have executed for UDP. So in this UDP, there is no concept called acknowledgement. So simply what? N0 will send packet to N1. So there is no acknowledgement. Yes. Okay. I'm just stopping this. So this is my NAM window. This is my network animator window, right? So network animator means in order to do your simulation graphically, right? So this is my play button. This is my pause. Then this is you can play back, play forward and backward. I can pause here. You can go to backward. Here you can go to forward, right? From this you can see this skip 2.0, right? So if you adjust this, you can adjust your simulation speed. Just I'm just scrolling down. If you see, the packets gets moved too slowly, right? So if I'm increasing the speed, can you see? You can get faster movers. Then after this, in this left corner, you can see zoom up and then zoom down button, right? That is for this simulation. So nothing is in NAM. Okay, just I'm stopping and then closing this window. Right. So I'm going this folder. The file name is what? So I'm deleting this tr and then this nam file. Yes, I have deleted, right? The file name is what? Simply I am having p2p-udp.tcl. Yes, I am executing the same file here, that is ns p2p-udp.tcl. If you see, after executing, the tr and then nam file gets created. Yes, simply you can execute this. This is what? Simple point-to-point protocol, right? So can anyone say what are the topologies you know? Can anyone say any topology? Topology name? We will design. Yes, any answer from student side? Yes, bus topology. Okay, how bus topology will work? So first I will go to bus and then I will go to ring, okay? Okay, mesh. Then after that, we will design bus, ring, mesh. After that, any topology name? Yes, star. Okay, we will design all these four, right? So first, bus topology. So already I have created bus topology, right? So simply I will execute. After that, we will design from scratch, right? So in order to check the bus topology, what I have to do? How I have to execute? NS bus dot TCL, right? Yes. If you see, this is my bus topology, right? So nodes are arranged, right? So I am just running the simulation. Yes. Can you able to see? Can anyone say what is sender and what is receiver from this simulation? Yeah, I will again run. Yes. Packet is coming from which direction and then acknowledgement is coming from which direction? Yes. So packet is coming from where? Node 5. So packet is where? So acknowledgement is coming from where? Node 6. So node 5 is transmitter and then node 6 is receiver. So let's check in my code. Just I'm closing this. I'm opening TCL. Yes. Everything is same. Yes. Just see. This is the connection line for what? Sender. So sender what? I have mentioned what? $N5. So N5 as what? Sender. This is the connection line for what? TCP sync. So in this what where I have mentioned node 6 as what? Sync. So shall I change now? So here I have from node 0 to node 6. So now I am going to change sender as node 0. So if I change this node 0 here, I have to use here also. So this is attaching line. So this is what? Detaching line. So I have to change in both sides. So I have changed what? Source as N0 and then sync as what? So I will change as N4, right? So simply I will change this as N4. The same way where I have to change, I have to use this in sync. So I am saving this file and then closing. I'm running the same code again. So ns bus.tcl. Yes. Shall we check now? Why there is no packet generated till now? If you see the time what? Time is what? 0.56. So if you go and check your coding, when you have started your transmission, only a time where 1 second. So that's why no packet gets generated till now. So I'm just playing. Closely watch time. Yes. So did you see? I'm going forward. So I'm going back. Yes. Take the time now. Time gets 1. What is this? Why node 0 sends this acknowledgement packet? Why this packet is too small? From 0 it's created. Where it's going? It's going to node 4. And then node 4 also send a small packet. And then it travel back to node 2. And then node 1. Yes, it reaches 0. After that, this is my actual data packet, right? So what is this previous? So does anyone know? So this is my actual data packet. So before sending data packets, why small acknowledgement packet saying node 0 is in node 4? So I think everyone aware of TCP connection, right? It has 3 phases, right? So what's the first phase? Connection establishment, data transfer, and then connection release, right? So in connection establishment, how TCP will work? The sender will send what? Synchronization packet. For that, the receiver will send what? Synchronization to the acknowledgement, right? So that is the small thing. So after this connection establishment, only what? Sender will start to send packets. So initially sender send 1 packet. So last time it sent 2 packets. Now see 1, 2, 3, 4. Why it is sending 4 packets? Because actual TCP's working procedure is what? Initially it will send 1 packet. After receiving acknowledgement, what it will do? It will send 2 packets, and then after receiving acknowledgement, it will send what? 4, 8. So up to it will increase to what? Receiver's advertised maximum window. Yes, that is it. I am just speeding up the simulation. That's it. Okay. So if you see this bus topology, so how many nodes I have created? How many nodes? So I have created node 1, 2, 3, 4, 5, 6, 7 nodes I have created. So I'm going. So what I have to do? So I have to create what? 7 nodes. So from node 0 to node 6. So in order to create these nodes, which lines I have to follow? I have to follow this line. That is, say I have to use this node name, and then after then what I have to use? I have to use $NS node. So by creating node 0, I'm using this for set n naught $NS node. After that, same I have copied and then I have pasted, and then simply what? I will change my variable name. So after that, what I have to do? So I have to create connection, right? So in order to create connection, so simply I will start from fresh, right? So I'm just closing this. So this is my sample topology. So I'm keeping this as sample topology, and then I am going to create a new file, right? This is my basic file, right? Point to point TCP file, right? So simply, right? Here in this file, what I have created only two nodes, and then I have linked these two nodes, and then what I have done? So I have created a TCP connection, and then SYNC connection, and then FTP connection. I have started, and then I have ended my connection. Yes, this is my sample program. So I'm going to save as this program. That's simply a test. Okay, I am saving. So this is my first step. So I will change this TCL file in the name what which name I want to. So after that, what I have to do? So I have to change .tr and then .nav file, right? So I am changing just what the same file name as my TCL file. That is test.tr. The same way I am changing my nav file. That is test.nav. So if you see here, so I have changed test.tr. Here I have changed test.nav. So and then in the finish procedure, so I have to use what? So I have to change here. Shall I change in UDP? File, save as. I am changing this as test.tcl. I am saving this. Yes, replace. So in this file, same. Two nodes are created, two nodes are linked, and then UDP packet, and then CBR connection is started and then stopped. So first step, what I have to do? I have to change my .tr file and then .nav file. So I am changing this as what? Test. So here I have changed to what? Test.tr, and then here I have changed test.nav, right? So after that, what I have to change? I have to change in the finish procedure, right? So here I have to change test.nav. Okay. So why this step means after completing the simulation, so what I have to get? So I have to get this pop-up window, right? So network animator pop-up window. For this, you have to use this line. So if you don't want to get this pop-up window, you simply can neglect this. Okay. So I have changed. Okay. What's my sample scenario? So how many nodes I have to create? I have to create from node 0 to node 6. So I'm going to create. Yes. So this is the line to create node, right? So simply I'm copying and then pasting. Copy. Yes. Pasting. So this is for what? Node 2. For node 3. Yes. Node 4, node 5, and node 6. Yes. I think 6 nodes, right? Yes. Node 0 to node 6. So I have created what? 6 nodes. So after that, what I have to do? I have to link nodes, right? So see the scenario, how it's created. So node 0 is created to node 1. So node 1 is created to node 2. Node 2 is created to node 3. Node 3 is created to node 4. So I'm just completing this scenario. So how I have to create? I'm simply copying this line. So pasting. Right. So node 0 is created to node 1. After that, what I have to do? I have to connect node 1 for node 2. So after that, node 2 with node 3. After that, node 3 with node 4. Right? Right? I have created from node 0 to node 4. Right? So I have connected from node 0 to node 4. After that, what I have to do? So I have to connect. Just a second. Okay. So after that, what I have to do? I have to connect node 1 with node 5 and then node 2 with node 6, right? So same step, I'm copying and then pasting. So I have to connect where? Node 1 with node 5. So after that, what I have to do? I have to connect node 2 with node 6. Till now, is it clear? Do you have any doubt? Yes. So I have created node 1 with node 5 and then node 2 with node 6. So everything is same. So next, what I have to do? So I have to set my source and destination. So can anyone say? Can anyone say what's my source? What should I assume? Shall I assume one as source and destination? Anyone just randomly say source and destination number, node number. So I will assign in this program. We will check whether it's working or not. Sender number, anyone? Reply please. Just randomly say any number. For sender, just type any number. I will assume a sender. Okay. So I'm assuming 5 as sender. Okay, receiver. Receiver, any number? Okay, 2. Okay. So sender where I have to change. This is my sender line, right? So I am changing this as what? 5. I have changed the sender as 5 and the receiver what? 2. Right? Only these two changes. Then everything is same. So I'm just saving. Right? So shall I check this program? So just I'm going, just closing the previous window. Right. If you check this, yes. So only I'm getting what? Test.tcl file, right? So I'm now going to execute this ns. What I have to give? Test.tcl. I'm just giving enter. Yes. What? So node is created randomly, right? This is not like, right, bus topology, right? So if you see the sample scenario, how it looks like? Yes, it's properly arranged, right? So in order to arrange this, you have to use. So you have to use this line command. Just I'm copying. Yes, I am pasting this. What this line means, okay? So you are linking these two lines. At the same time, you can align your position, right? For example, node 0 is connected to node 1, right? So I can fix the position of node 1. So if you see this example, so node 1 is where it is arranged exactly at right to node 0, right? So that's why I'm giving what? Node 0 to node 1 as what? Orientation is what? Right. The same way, node 2 is arranged to what? Node 1. Node 3 is arranged to node 2. Node 4 is arranged to node 3. Simply I can copy paste and then change this lines. So I'm copying, just pasting. So next line what? Node 1 and node 2. That is N1 to N2. That is what? Node N2 is positioned right to the node 1. The same way, node 3 is arranged right to node 2. The same way, node 4 is arranged right to node 3. Right? So I have given these arrangements. After that, what I have to give? Node 5 is arranged where? Top of the N1, right? So for this, you have to give. So N5 is arranged where? Up top, right? So for this, you have to use up and down command. Up. The same way, node 6 is arranged where? Top of node 2, right? So I have to give N2 and then 6. I'm giving up. So now I am saving. So I am executing the same program. Yes, I am executing NS test dot TCL. Yes, can you see the difference? This is just for what? Your animator purpose. You can align your position, right? So we have given what? Node 5 as source and then node 2 as receiver, right? So we will check whether it's working or not. Yes, it's clear? It's working. Yes? Okay. So we have completed bus topology. What is next? Next topology, anyone? Any topology? Next. Next topology name ring. Okay. It's simple, right? So simple, the same way I have created n 6 nodes. Then I just have to what? I have to change the connection, right? For ring topology, I have a sample scenario. Yes. This is my sample ring topology, right? So in this what? So nodes are connected in sequential order. Last node will be connected to what? First node. The same way, in this program, just we will take what? Same 6 nodes. So for ring topology, how I have to connect? So I have to connect to node 0 to node 1, node 1 to node 2, node 2 3, node 3, node 3 to 4, 4 to 5 and 5 to 6, right? Same way, if you see the first line, node 0 is connected to node 1. Second line, node N1 is connected to N2. After this, N2 is connected to N3. After this, N3 is connected to N4. And then what I have to do? I have to connect this N4 to N5, right? For ring topology. After this, N5 should be connected to N6. After this, N6 should be connected to what? N0, right? So I am simply copying and then pasting. Right? So N6 should be connected to what? N0. So for ring topology, you don't need any orientation, right? So simply I can delete or I can simply I have deleted, right? The same test program, I didn't modify anything, right? So same sender is what? Sender is same 5, receiver is 2. So I have converted my what? Bus topology into ring topology. Simple. What you have to do? You have to only change this your link. So I am saving. Just I am going back. Then again running my same sample test program, that is NS test.tcl. Yes. I'm giving relayout. Yes. If you see the same program is converted into what? Ring topology. Shall I run? The source should be what? 5 and then receiver should be 2. Yes, it's working. Yes, I think you can see. Right? Packet is going from 5 to node number 2. Yes. Okay. Next topology. Next any name. We will try. Yes, star topology. Shall I show the sample star topology? Yes. Yes. This is star topology, right? Star means how it will communicate. For example, if you want to communicate from node 4 to node 3 means it will go via what? Node number 7 and then it will go. This is my sample topology, right? For example, what you have to do? You have to create every node to what? Center node, right? Same topology. I am modifying the same test file, right? So I have created 6 nodes. For center node, I am creating the last node, right? So I am just simply copying this line, pasting. So you can change the star topology to n number of nodes, right? For example, already I have 6 nodes. So I have created a 7th node as my center node, right? So I have created node 7. So how I have to connect? See the sample topology. How I have to connect? So I have to connect all the 6 nodes to what? All the 6 nodes to center 7. So what I have to do? I have to change node 0. So I have to change only these lines, right? So I am changing first line. I have to change node 0 to what? I have to connect to node 7. So I have to connect node 1 to what? Node 7. Node 2 to node 7. Node 3 to node 7. Node 4 to node 7. Node 6 to node 7. And then node 6 to node 7. Right? Simply what I have changed, I have inputted only one node and then I have changed the connection position. Simply I am saving and then I am again going to terminal and then again I am running my sample program. So how to run? NS test.tcl. Yes, line limit. Yes, I am running the same program. So previously I have created what? So node 0 to node 1 connection. I have given orientation for this, right? So for this, there is no connection to node 0 to node 1. So that's why it showed error. So I am going back and then I again running. Yes. So I am giving relay. Yes. We have created what? Star topology. Shall I run? The same sender what? Sender is 5 and then receiver is what? 2. Yes, you can see. Yes. Okay. The next topology. Next topology name. We have done bus topology, ring topology, and then star topology. Any other name? Any other you do you know? Yes, answer please. Any answer? Yes, mesh topology. Shall we try mesh? So I will show sample scenario for mesh. That is, yes. Okay, mesh means what? So each and every node should be connected to what? So every other node in the system, right? So here if you see, so node 0 is connected to node remaining every node. So node 1 is connected to remaining every node. The same way we have to communicate what? So link from one node to remaining every other node. So I am going back to my test program. So in this test program what? So we have 7 nodes, right? Simply I am taking 6 nodes, right? So for first node, what we have to do? We have to connect from node 0 to, so from I have to connect my node 0 to remaining 6 nodes, right? So simply I am deleting this. Yes. Node 0 to node 1 I have connected. So after that I have to connect from node 0 to node 2. So after that node 0 to node 3. So after that node 0 to node 4. So after that node 0 to node 5. After that node 0 to node 6. So I have created from node 0 to remaining every other links. So after that what I have to do? I have to connect node 1 to every other node. So already I have created nodes 1 to node 0. So I don't need to connect again. So what I have to do? I have to connect node 1 to what? Node 2, right? So after that, what I have to do? I have to connect from node 1 to node 3. So after that, node 1 to node 4. So after that, so node 1 to node 5. So after that, node 1 to node 6. So I have created node 1 to remaining every other node. So after that, what I have to do? So I have to connect node 2 to remaining every node. If you see, node 2 is already connected to node 0. Node 2 is already connected to node 1. So I have to connect to node 2 to what? Node 3 and then further. So I am connecting. Yes, node 2 to node 3 I have connected. Node 2 to 4 and then 2 to 5 and then 2 to 6. So 2 to I have created everything. So then after that what I have to do? I have to connect from 3 to remaining everything. So from 3 I have already created to node 0. I have created to node 1. So I have created connection to node 2. So then what I have to do? I have to create connection to node 4. That is, I am just copying this. Yes. Yes, node 3 to node 4 I have connected. Node 3 to node 5. Then node 3 to node 6. So after that, so I have completed node 3 to everything. Then after that, what I have to do? So node 4 to node 5. Because node 4 to previous 3 I have already connected. So next node 4 to node 6. Then last connection is what? Node 5 to node 6. Yes. Is it clear? Simply I have converted my sample previous star topology into what? Mesh topology. So I have saved this program. So I am going back and then I am simply running this program. So ns test.tcl. Yes. Relayer. Is it clear? Yes, I am simply running this. So we have assumed what? Node 5 as source and then node 2 as receiver. You can see. So packet is sending from node 5 to node. Yes. Yes. Next topology. Any other name? Do we miss anything? See what's hybrid topology? Hybrid topology means we are combining two or more topologies together, right? So I have a sample hybrid topology. So I will show that. Yes. And this what I have done. This is what. So from node 0 to node 6 what? This is sample scenario for what? Bus topology. So in this bus topology, what I have done? So in this file, I have again added what? Star topology, right? So I have considered 5 as my center node and then I have added what? 3 more nodes. Star, I think we have completed star, right? Yes or no? I think we have completed star. So in this, yes ma'am, okay. So this is bus topology and then we have combined the star topology, right? So previously, which program I have done? We have done. Yes. So previously we have this what? Mesh topology. Shall we include bus topology in this mesh topology? Right? So already we have created what? 6 nodes, right? So after that, we are going to create 3 more nodes and then we are going to link these 3 more nodes to what? This node 0. So after this node 0, so I'm going to place node 7 and then node 8 and then node 9. So in a bus order, okay? So I'm just closing this. So simple, again, same program. So I have to create what? 3 more nodes. So I'm just copying. So node 7. Node 8. Node 9. So I have created 3 nodes, right? So already we have created topology for what? Mesh topology. So now we have to add bus topology in this mesh topology, right? So it's simply copying and pasting. Okay, anyone say in which node can I add bus topology? So in the sample scenario, we have from node 0 to node 6. In which node I can add my bus topology? Say any random number from 0 to 6. Random number from 0 to 6. We will add to that node. Yes, it's not. Can you message? Anyone reply, please? Any random number? 6. Okay. So I have created 3 nodes. Then I'm going to add this bus topology to what? My 6th node. So I have copied this line. So what I have to do? So I have to connect. Already I have given connection to node 6, N6. So now I have to connect node 7 to what? node 6. So I have to give connection node 6 to node 7. Then after that, so I have to connect. This is bus topology, right? So node 7 should be connected to node 8. Then after that, node 8 should be connected to node 9. Simply I have copied and then I have changed based on your topology model, right? So after that, what you have to do? So in order to give orientation, what you have to do? You can use this line. So that is what this lines, orientation line. So orientation line means what? How you have to get? So after this, yes, after this node 6, you have to get node 7. So what should be you have to paste? You have to paste node 7 in the right of node 6. So then node 8 should be right of node 7. Node 9 should be what? Right of node 9. So I am going and then I am changing that. So node 7 should be, already we have node 6. I have to place node 7 in the right. Then after that, I am copying again the same line and then pasting. Yes, so I have to change node 7. So node 8 should be what? Right of node 7. The same way, node 9, node 9 should be what? Right of node 8. I have changed. I have saved this program. Again, I'm closing already previously opened the tab. Yes, I'm running NS test.tcl. Yes, that is not saved. Okay, in order to get this alignment, you have to give position to all the nodes, right? Simply we can edit from another. For example, simply we will assign, see, I have created 9 nodes, right? These nodes are created, I will say, yes, simple. I have created simple start topology. In this topology, I am going to add this what? My bus topology. So simply I can connect what? So I can add a simple 3 nodes. So if you need a full orientation, you can give position to each and every node. Okay, you can test this in your lab. Yes, I have created 3 nodes. The same way I will add these 3 nodes to node 6. Yes, node 6 to node 7, and then again node 6 to node 8. Again node 6 to node 9. Okay, I'm saving this. Then I'm running the program. Yes. Can you see the difference now? This is mesh topology, right? From 0 to node 6 is a star topology, and then again, so node 6, 7, 8, 9 are in another star topology. These two topologies are combined together. You can create hybrid topology. In this way, you can create any two topologies, and then you can create any two or more topologies, and then create a hybrid topology. Right? Do you have any doubt till now? Yes. If you can any doubt, you can ask. Or else I will go to packet analysis. So till now we have a deal with what? .tcl file and then .nam file, right? So still .tr file is missing. So we have to analyze that. Yes. Any doubts or any queries? Sure. Then I will assume that there is no queries, right? So we will go for this tr file. I am closing this, right? If you go your folder location, you can find .tr file. If you open this, yes, you can find, right? What are this? You don't understand anything from this, right? So in order to understand this, you have to see the file format. So basic file format is, I will show. Yes, this is your file format. So first point, that is right. So first data in your line is what? It's an event. Event means what? You can receive, you can send, right? So send is mentioned by what? NQ. And DQ means what? So from the sending from one layer to another layer or one node to another node, right? So that is for DQ, NQ and DQ purpose. The next second item is what? Your time. Then third item is what? Your node. That is from node. For example, your source node, right? Then next is 2. For example, if I am transmitting from node 1 to node 7 in bus topology, I have assumed as what? Node 1 as transmitter and then node 7 as receiver. The packet will generate from node 1 then and then it will go to what? Node 6. But so if the packet is how it should go? It should go from node 1 to node 2, node 2 to node 3, right? So if you open the packet which is going from node to node 3, if you open the packet, the data will be what? Node 2. So it is coming from where? From node 2. So it is going to what? Node 3. So you can find the data as node 2 and then node 3 here in the fourth column. After this, you can find the fourth column is what? Packet type. So whether it is a TCP packet or it is a UDP packet or it is a CBR. CBR means what? Constant bit rate. That is UDP packet. Or it is, whether in the TCP, whether it's a data packet or acknowledgement packet. You can understand from this fifth column. After this, next data is what? Your packet size. That is your packet size. If it's acknowledgement, the packet size will be what? Only 40. Why it is 40? Can anyone know? How many headers will be added? What is the header size? So in transport layer, 20 bytes of header will be added. In network layer, 20 bytes of data will be added, header will be added. That's why the acknowledgement packet contains what? 40 bytes, right? The next. So packet size means what? TCP packet size. We have given what's our packet size? In our sample test scenario, we have given 500 as ever packet size. We will check whether the 500 is came or not, right? After this flags, right? So after this 6 feeds of flags, currently flags are not used, but you can use, right? What is flag? So urgent flag, route request, destination not reachable, right? These are the information you can get the information from this flag. Then after this, flow ID. So flow ID means, for example, at the same time you are communicating to 10 number of nodes. You want to differentiate each nodes with each color means you can use this flow ID, FID concept, right? You can give connection flow ID to different traffic and then you can easily retrieve that. Then after this, source address and then destination address. Source address means what? actual sender, and then destination means actual receiver. What is this 3.0? If you see, host address means node dot port, right? So first one is what? My node number. Second one is what? My port number, right? So everyone know what is port? Port number is present in which layer? Anyone knows? Port number? I think everyone familiar of this OSI architecture, right? So the physical layer, bottom layer, that is no address. Second layer, what is my second layer? Data link layer. What address is present in data link layer? Yes? Anyone? No? So port address is present in what? In transport layer. MAC address is present in network layer, right? So in order to differentiate, for example, source is assumed as N1, that is node 1 is act as a source means if I am having two sender at the same node, I have to differentiate these two connections, right? So I have to use this port concept. For example, for first connection use 3.0, for second connection it will use what? 3.1. The same way at the destination, right? Then next one is sequence number. What is sequence number? Sequence number means it comes only for TCP. What is sequence number? For every data packet sends, it will mark the packet number. That is, for example, if I am sending the first packet as 1, the acknowledgement will come, right? The acknowledgement number should be what? Next sequence number. For example, if I am transmitting here as a packet number 15, I should wait for what? Acknowledgement 16. After receiving acknowledgement 16, what I will do? I will I will send my what? 16th packet, sequence number packet. Then last one is packet ID, right? Packet ID means what? So how many packets I have transmitted, right? So packet ID is different and then sequence number is different, right? Sequence number is constant. Packet ID means if a packet get dropped means the sequence number won't change, but packet number, packet ID will change, okay? Okay, this is the basic frame format. We will check. Yes, we will check in our program. Yes, I am considering this line. What it says? Yes, first is or, that is what? Received. Okay, some node is received. Which node is received? The node information should be available where? At position. Check the format, right? It is available in from which node? It is available in position 3, right? So position 3. So I have received a packet from node number 5. So where I have received a packet in 0. So at which time? At time 0.14, right? Second. So after this, what CBR means what? It's a UDP packet. What is the packet size? My packet size is 1000. Then next is what? What is my next ID? It's my flow ID. So I have given my flow ID as what? My flow ID as 2. And then where it is coming from? It is coming from source, that is 5. And then it is going to what? 2. Right? So because what we have assumed sender as 5 and then receiver as 2, right? So it is coming from 5 to 2 at port number what? So 0.0. Okay. And then last, so this is basically what? Initial packet. So it doesn't have any number. If you go further, you can find, right? This is my sequence number and then this is my packet number. If there is no packet drop means sequence number and a packet number will be same. If you see, everything is same because there is no packet drop acquired in this network. Yes, is it clear? So if I check this line, I am checking this line randomly. What it shows, if plus means what? Enqueued. That means enqueued from where? So it have enqueued packet from 5 to where? Packet number 0. at time what? 0.948 second. CTR packet. The size of a packet is what? 1000. And then the flow ID is 2. It is coming from packet number 5 and then it is going to a packet number 2. Its sequence number is 106 and then its packet number is 106. Okay. In this way you can analyze the packets, right? So this is your trace file. From this you can analyze your performance. So what are the network performance parameters? Simply throughput, output, packet drop, delay, right? How you can measure throughput? Yes, how you can measure throughput? That is number of packet received minus, that is number of packet received per time, right? So how I can find number of packet received? So in the TR file, you can find R, right? So R means what? The packets received, right? So in this scenario, what I have assumed? I have assumed node 2 as my receiver, right? So what I have to check? So I have to check how many R's I have received at which column? Fourth column as 2. So I can use this script command. For your laboratory purpose, this is not necessary. Simply you can just write the TCL file and then execute, right? So if you want to analyze this performance, we will take in some more time. Okay, I think I have given an overview of this, right? So if you have any queries or doubts, you can ask me now. Yes, do you have any doubts? Shall we wind up? Or if you say any new topologies, I will then, if we will just try to demonstrate that. I think no queries, right? Then thank you everyone. Ma'am?
Thank you, ma'am.
So NS2 is installed in your laboratory. If you are interested, you can go and try at any time, right? Thank you all. I will share this sample coding to ma'am, okay? You can get, I will share only one coding. After that, you have to design every topology, right?